welcome back to my channel. So today we are going to start with the new chapter named gravitation. Okay, in this chapter we are going to look at the topics gravitation, circular motion and centripetal force, Kepler's law, Newton's universal law of gravitation, Earth's gravitational force, free fall and escape velocity. All the topics would be covered in different videos. Okay, so the first video is about the gravitation. So what do we know about the gravitation? Gravitation is a force. So first we need to look at the force. What the force does. What are the effects of the force? Gravitation is a force. So we are going to discuss first the effects of the force. So what a force can do? It can set a body in motion, right? So if a ball is lying on the floor, I can go and kick it and put it in the motion. It starts rolling, right? So it can even stop the body in the motion, right? Suppose I'm riding a bicycle. So when I apply the brakes, what I'm doing? I'm stopping the motion of the body. It can change the direction as well as the speed of the body, right? So if a bowler is bowling a ball, the batsman would hit the ball. So batsman is actually changing the direction and the speed of the ball, right? It can even change the size and the shape of the object. Suppose I have that rubber ball. So if I press it, the ball, its size and shape both gets changed. Okay. So these are the effects of the force. Okay. Now how many types of force are there? See, force are classified into two types depending upon the contact. Like, see, these are contact forces. First is contact forces and second is non-contact forces. Simple as it can be. When the two objects are in contact with each other and the force is experienced, they are called as contact forces. And the force which is experienced even when the objects are not in contact with each other is called as the non-contact forces. So what are the examples or the contact forces? First one is frictional force. Okay. Second is normal reaction force. And the third one is tension in the string. Fourth is tension in the spring or the force exerted by the spring, force by spring, and the force during the collision. Okay. So see, I'm going to discuss in brief what are these forces. And okay, you all must be wondering why do we need to know about these forces. See, whenever an object is falling or whenever we are looking at an object, there are different types of forces acting on it. So we need to know what kind of a force is it. So we need to understand the forces. And what are the non-contact forces? Gravitation is the non-contact force. Second is, I can say, electrostatic force. This also does not need the contact between the objects. Electrostatic force. Nuclear force. Okay? These are the non-contact forces. Fine. So what do I mean by the frictional force? See, I have this marker in my hand and I am going to pull it here. So this duster is going to exert a force in the opposite direction like this. So that along the surface. So that force is the frictional force. See, whenever you are pulling, I'm pulling this duster in this direction. So the frictional force would be in the opposite direction. It's always going to act in the opposite direction to the force applied. Basically, it's stopping the motion of the object. Okay? So that is nothing but the frictional force. So if I have a book on my table, suppose this is my book and this is my table and I am pulling it here. So my frictional force would be in the opposite direction like this. Okay? Now what is the normal reaction force? See, when I am holding this duster in my hand, the weight of the duster is acting downwards, right? So my hand is exerting a pressure, force upward, which is normal to the duster, to hold this duster in my hand. So that is called as the normal reaction force. So if suppose I am standing on the floor, so my weight is going downwards, right, and my body is putting the surface is exerting a force in the upward direction. Okay? Now what is the tension in the string? So I have got this string attached to a rigid support like this, and I am going to put a weight. I am going to attach a body to the string of the weight W. Okay? So when I attach this body, the string gets stretched. Okay? Suppose it gets stretched and it comes to this position like this. So the string in this position is going to try to pull the body upwards. Okay? That is nothing but the tension in the string, and that is always going to be equal to, that force is going to be equal to the weight of the body. Fine. So the tension in the string is when something is hanging at the end of the string in its stretch position is going to try to pull it upwards. Okay, and that force is always going to be equal to the weight of the body. Fine. Now what is force by a spring? So I have my spring like this attached. The one end of the spring is always fixed. Fine. This is my spring like this. Fine. So either it can be compressed or either it can be stretched. So suppose I am taking the condition in which it is pulled. Okay. So I am pulling the spring like this. Fine. So it has covered this much of displacement x. So in that case, what the spring does, it's always going to try and put the force in the opposite direction. I am pulling it in this direction. So spring is going to exert a force in the opposite direction, and that force would always be proportional to the displacement. Fine. And its direction is going to be opposite to the direction of the applied force. And suppose if I compress it, I take this condition, I have compressed. Fine. So this much of compression I have done. So now the spring is going to exert the force in the opposite direction like this, and it's going to be proportional to the displacement made. Fine. Now what is force during the collision? Okay, force during the collision. See, these two balls are there. Suppose I consider during the collision, this body, they are colliding like this. Okay, this body is going to put the pressure force on the ball B, and this body is going to put the force on the ball A, and like that they both move in the opposite direction with the equal forces. Fine. So that is the force during the collision. Now let us consider and let us talk about Newton's laws of motion. And why are we studying the Newton's laws of motion? See, they are the very important law. Basically, see, the force with which the earth is attracting us is nothing but, it's called gravity, right? So gravity is nothing but acceleration. So it is attracting forces equals to m into a. How is it derived? It's derived from Newton's laws of motion. What Newton, he has given us the three laws. First is law of inertia. It is also called as law of inertia, okay? So inertia is what? Inertia is basically the resistance. Resistance means what? It's going to always try and oppose the force, okay? So what it says is a body continues to be in its state of rest or of motion unless it's acted upon by a force. Means if a ball is lying on the floor, it would like to be in its state of rest. Until and unless we go and kick it, we go and a force is acted upon it. So resistance is what? I don't want to change the position, or I don't want to change my motion. It's called as the resistance, and that law is given as law of inertia. Second is law of momentum. Law of momentum. Now what do we understand? It's called the fundamental law of the motion. This law, second law, is the fundamental law. It's the most important one. What it says is the rate of change of momentum of a body is directly proportional to the force applied. Suppose I'm applying the force F. So it is saying that this force is directly proportional to the rate of the change of momentum. Now here my P is my momentum. Now we are going to discuss in detail what is this momentum. Now see, momentum, keep it in your mind in simple words, it's mass in motion. Momentum is nothing but mass in motion is your momentum. So see, all the objects have got mass, right? So all objects in motion, I can say all objects in motion have got momentum. So if a ball is rolling on the floor, it has got what? It has got momentum. Mass in motion is nothing but the momentum. So it is saying that this, okay. So momentum formula is what? Mass in motion, right? Motion means it's having particular velocity into v. So my momentum becomes mass multiplied by the velocity is my momentum. So by the second law of motion, it is saying that this force is directly proportional to rate of change of momentum. Okay. Now we are going to differentiate this. See. Right. So delta, that means what? M into delta V upon delta T. Now what is this delta V upon delta T means? Means change in velocity. See, whenever there is a change in velocity, what it shows? Change in velocity is nothing but our acceleration. Okay. So can I write this delta P upon delta T to be equals to mass into acceleration? Okay. So what my this becomes now? Second law of motion becomes this is my A. Okay. So when I remove the proportionality constant, we always put a constant. So delta P upon delta T we have got as M into A. Okay. So my force is nothing but M into A. Okay. Force is always going to be in the direction of the acceleration. This is the fundamental law of the motion. Now third one. Okay. What is the third law of motion? What the third law says? See, the third law is saying us whenever there is an action force, there is always going to be an equal reaction force. Okay. And in the opposite direction. Third law is saying us, so suppose I am having a body 1 and this is my body 2. Okay. So this F12 is what? The force exerted on the body 1 by the body 2. So this is always going to be equals to F21. Now what is my F21? The force exerted on the body 2 by 1. Okay. These both are going to be equal but in opposite direction. So it says that the forces always exist in pair. Okay. These all the laws are going to be used in the coming topics. Fine. So these are the laws given by the Newton. Now next we are going to see is non-contact forces. That is nothing but first one is gravitation. So see what has happened basically. Newton when he saw it was that the earth is attracting the apple, but he concluded what it's not only does the earth attract every particle, but the every particle in the universe is attracting earth. Okay, so basically everything around us, even I'm attracting, if someone is sitting beside me, I'm going to attract that object. Okay, so every particle in the universe is attracting every other particle, and that attraction is known as the gravitation. Fine, and the force with which it attracts is called as the gravitational force. Okay, now we have to see, suppose I'm having a stone in my hand. Okay, and when I leave that stone or when I release that stone, what are the forces when it's in my hand? Suppose this is my stone, it's my hand. So what are the forces acting on this stone? See, it's the normal reaction force, okay, which is acting upwards. Fine, and it's the upthrust of the, okay, and the gravitational force which is acting downwards. And when I'm going to release that stone, what are the forces acting? The beyonds of the air which is acting upwards. Okay, the resistance by the air is going to act on that stone, and the gravitational force. Fine, so whenever we release something, the upthrust of the air is going to act upwards. It's going to try and pull that stone upwards, but the earth's gravitational force is going to try and pull it downwards. Fine, and the next thing we have to see is, okay, see, is there a gravitational force between two people sitting on the table? Okay, and if it's there, why are they not falling towards each other? See, when someone is sitting on the table, what are the forces acting on that person? See, the biggest force is the force of friction between that person and the table, right? And see, this is the force of friction. Fine. This is my A object and this is my B object. And this person also has got force of friction. Fine. Because of the table. Why are they not falling towards each other? See, gravitation is going to attract, okay, between these two objects should move towards each other. But the force of friction is acting in this direction, and the force of friction is acting in this direction. And it's so large that this gravitational force cannot overcome this force of friction. That's why we don't start falling towards each other, right? See, when we are standing on the floor, okay, suppose two people are standing on the floor, why are they not falling towards each other? Because the force of friction between me and the floor is way greater than the gravitational force. Basically, the gravitational force is a very weak force. It's not a strong force, okay? So, fine. These were the things we were supposed to discuss in this topic, okay? So if you like my video, do give a thumbs up, subscribe to my channel, and do not forget to share it with your friends.